All right, so this is our second part of our final exam review. So they tell us in this problem that f is differentiable. And so that's sort of the key to this problem is, okay, the function is differentiable. And then we know that at x equals 3, the function value is 8 and the derivative is 5. Which of these could be false? Well, it's important to remember that once we know it's differentiable, we also know it's continuous. And the definition of continuous is that the limit as x approaches any particular value of the function equals the function value at that point. And that's exactly what this first one says. The limit as x approaches 3 of f of x equals 8. Well, 8 is f of 3. The second one, in this case, yours might be shuffled around, but here, the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. Well, that has to be true in order for the limit to exist at all. And so because we have to be differentiable, or sorry, because we are told we're differentiable, we must then be continuous and the limit must exist. So kind of just like taking this given piece and peeling it back to, okay, differentiable means continuous, means the limit exists. Now for this next one, and also it's this one and this one. Those are just the limit definition of the derivative. If you remember when we first learned what a derivative was, we learned it as a limit. It's the limit of the slope. And we said there's two different ways to write that. That's what this is, and that's what that is. So those are just the limit definition of the derivative, and we know that the derivative at 3 equals 5. So yes, that's for sure. And then this one is just nonsense. I don't know why that would be 5. But just going through process of elimination, we know that the other ones are true, so that's the one that is false, which is what they want in this case. All right, we'll fill in the blank here. So they're asking us at 4 different x values, 2, 4, 5, and 7, whether we are continuous or differentiable or both or neither. And so at x equals 2, we have a jump. We're discontinuous there. And once you're discontinuous, you can't actually be differentiable. So actually, as we look at our answer choices, this one doesn't make any sense. You can't be differentiable and not continuous. You have to be continuous to be differentiable. So that one we're never going to use. And so this one, neither continuous nor differentiable. It's not continuous, and thus right away it's not differentiable. X equals 4. They tell us in the problem that we have a vertical tangent line at x equals 4. Well, a vertical tangent line is one of the ways that you are not continuous even though you are differentiable. So we are continuous but not differentiable. Here, x equals 5, we have a horizontal tangent line. Well, that just means that the derivative is 0. It doesn't mean it doesn't exist. So this one is both continuous and differentiable. And then x equals 7. We sort of have a cusp and a hole. So the cusp makes sure that it's not differentiable, but the hole makes it not continuous, which then also makes it not differentiable. So that's, again, neither continuous nor differentiable. All right. Okay, so here they give us this function h of x, and we want the derivative of it. And the key is that they tell us that h of x equals f of g of x, and we want h prime of 1. So I'm just going to sort of ignore this graph and this thing for a second and just say, okay, here's h. How do I find its derivative? Well, h is a composition, which means I need chain rule. So h prime, by definition of chain rule, is going to be f prime of g f prime of g of x, times g prime of x. That's just the definition of chain rule. The derivative of the inside, the derivative of the outside with the inside left in. So then h prime, oops, sorry, let me undo that. H prime of 1, just plug in 1 to all this stuff, is going to be f prime of g of 1 times g prime of 1. And then I just need to figure that out. So now, here's where I go back and I look at my graph and my given equation. So I need to know what is g prime of 1. Well, g is this linear function. So, well, g prime is just always 2, regardless of what x value we're talking about. So this is 2. Now g of 1 is 3, so I need to know f prime of 3. And f prime, well, that's the slope of f. F is a linear function, they tell us, consisting of 2 line segments. And at x equals 3, we're over here on this right side here. X equals 3 is 1, 2, 3 right there. What's the slope here? Well, the slope this whole time, I believe if I'm counting correctly, over 1 down 2 is negative 2. So then this is negative 2 times 2, which is negative 4. This one, just a little bit of power rule. Just got to be careful with your negatives and your fractions. So we're just taking the derivative here, bring down the 4/5, y prime or dy dx is going to equal 2/5 x to the negative 1/5 plus 15 x to the negative 6th. And I rewrote that x to the 5th as x to the negative 5th in the numerator then. And then I just need to look at this and see, okay, which one of these does this work for? And I believe that's this one. I've got my 2 in the numerator, my 5 and my x to the 1/5 in the denominator, 15 in the numerator, x to the 6th in the denominator. Yeah, that appears to be correct. Similar to the one with the table, or sorry, with the equation and the graph, I'm given this sort of ugly looking equation here. And I just need to stop and think, okay, how should I take the derivative of this thing? And I can see, first of all, it's a product. So I need a product rule to take the derivative of this thing. So now I'm just going to go ahead and write that out. Taking the derivative of each piece individually, multiplying it out how I should. So product rule says derivative of the first piece 2 f prime of x. Leave the second piece alone, 1 plus g of x. Now switch. Leave the first piece, 2f of x plus, oops, I think my stylus is running out of batteries here. We'll see if we can get through it. 2f of x plus 3. And the derivative of the second piece, just g prime of x. I just have to switch to my finger here. And then we just plug in the pieces where we see them here. So we're given f prime of 1 is negative 2. We're given g of 1 is negative 3. We're given f of 1 is 3. And g prime of 1 is 4. So you just plug all those things in and you'll get 44. Once again, this is product rule because you got things being multiplied here. But then it's also chain rule here. Here's the sneaky part, is this chain rule. When I do this derivative, I'm going to have f prime of x is going to be 2e to the 2x times x cubed plus 1 plus, leave the e to the 2x, take the derivative of the next piece, 3x squared. And then there's a little bit of simplifying and figuring it out as you plug in the 2 for the x all the way across here, but I believe you get the 30e to the 4th there. A little quotient rule here, always a good time. So it's low d high, so leave the x squared plus 1 alone, times the derivative of the top, which is just 1, minus high, x plus 1, d low, which is just 2x, square the bottom and away we go, x squared plus 1 squared. Just going to have to multiply out the top and then combine some like terms. And when you do that, I believe, let me check my notes, I wrote it out earlier, you're going to get this one here. All right. Okay, so that's all I wanted to do for this one. Keep this 2 separate parts, so I'll do the next couple questions in a separate video.